I'm going to start with questions. Who's awake? Okay, that's just to make sure that if I ask a question, there's only 5 people awake, so I'm not supposed... Who's a human being? Okay, that's better. So, not sure, okay. For those who are at OSMC for the very first year, you might not have seen me before. I've been here before, I lost count how many times. I'm Kris. Ages ago I was a developer, and then I evolved. Good or bad, you choose. Last couple of years I've been working for Ollie, which is a spin-off of Inuit. Inuit is one of the larger open source consultancies in Europe. Ollie is the spin-off that's focusing on open source observability. And I pretty much do everything there technically, building the platform, consulting for customers, stuff like that. I'm not going to say my spare time, but next to that, I'm also, I started DevOps Days 15 years ago together with Patrick, still run config management camp together with Tosh. That's, what are the dates, Tosh? 4? No, 3? 3, 4, 5 February in Ghent, where we have great beer and chocolates and lots of infrastructure content. We're finalizing the schedule. It's going to be published in a couple of weeks, I guess. I know a bunch of people that are going to be there because they're speaking. Most people shout at me because they realize the problem they're figuring out, they're struggling with, and the root cause in their post-mortem is it's fucking DNS problem. So yeah. And you can find me on most social media as username Kris Buytaert. So, why the title of this talk? Does anybody still have this t-shirt? Did anybody have this t-shirt? One person admits he had the t-shirt. I mean, I had this t-shirt probably 15 to 20 years ago. Back when being root was the cool thing and we were reading the Buytaert operator from Hell Guide and doing that kind of stuff. Sorry? Okay. More gentle Buytaert operator from hell. So that kind of what brought me to, well, this is the talk or the title. We used to be root, we used to be doing all this hard stuff, debugging, figuring out where problems were going, and things have evolved. I mean, there's this new hype in town, right? Observability. You're laughing, that's good. I mean, we had the previous couple of hypes, Docker, everything was Docker. Then we figured out Docker wasn't enough, we did Kubernetes, and we made things much more complex. And now it's Ollie. I mean, who's not doing observability? A couple of people say they're not doing observability. I mean, I thought everybody was doing observability these days, but apparently not. So let's take a step back. Actually, I don't think I need to do this introduction here, but monitoring to me is like I look at the state of a service. I look at something and see if it's still there. Does it work? Does it still do what I'm expecting it to do? It's like answering the question, what is going on? Observability is like figuring out how these services behave. Like, look at the ecosystem around it as if you were in their place. Figuring out why things are going on. So we're nearing the end of the conference, and I'm pretty sure that by now you all know the 3 pillars. Like, are there 3 pillars? Are there more pillars? Who knows? Like, metrics, logs, traces. Did we discuss the 4th pillar already? Anybody got an idea what the 4th pillar is? Profiles? Yeah. Who knows? You know what for me the 4th pillar is? Basic health checks. Actually, I don't think there's pillars. I think it's more layers. Like, you start with basic monitoring, you add some things on top, and you grow till you have a much more mature ecosystem. And it's not one or the other, it's a mix of things. And it starts to get complex once you start building these things. So monitoring and observability, how are they actually even connected? I mean, monitoring is something you need to do. You need to have those health checks in place, or you don't know if your system is down. And if you're really lucky, then it's enough. But Julien Pivotto, the Prometheus maintainer, one of my colleagues actually says, well, observability is trying to remove that luck, figuring out how to prevent things from failing. It kind of is that next layer up if you already have monitoring. So we all know to do this, right? And ages ago, there was this awesome tool. I don't know if you still remember that if you've been here. This packet beat, before they got acquired by Elastic, and Elastic decided to drop all the nice features and cripple it, that was like an awesome tool. It worked. I could drill into databases, go from an HTTP request. This was all PCAP based, it was all TCP dump based, and you just go, this is a request, and you drilled all the way down to this is database query that's triggering it. And then the new release came, and it was gone. And then they were proprietary on us, and then they returned. But I missed this. And trying to build an ecosystem that did this, that worked like that, that's a lot of work. So we didn't have this for a while. We had great monitoring, we had great metrics, and a lot of the cases where you walk into an environment, you're like, okay, so where's this metric? Ah, it's gone, we lost it. Or people switched to Prometheus, and they were using Graphite before, and they had years and years of data, and they forgot to change the default retention, and now they lost all their data. And they didn't have long-term metrics anymore. We lost learning from our metrics. Or we had logs, and we didn't actually have them all, and we couldn't search them, and our stacks became way too complex. I mean, I'm pretty sure you have broken dashboards. I'm pretty sure you're not shipping all the logs you want to. And I'm pretty sure that you have metrics around that you don't know anymore, because you're not using them. So yeah, lots of things have changed. And building a stack that does all of this is complex. That's what we try to do. So really, my message before we get to observability is, please fix your monitoring first. I gave an Ignite about that a couple of years ago. I've been giving other talks about that. But before you start to get up to that next layer, please make sure you have a single source of truth that automatically generates your monitoring, where you have no manual configuration in place. Fix your metrics. Make sure you have those MySQL metrics you care about, because they moved. Fix your log shipping. And then we can start talking about observability. So we have an whole ecosystem. Monitoring, metrics, things are in place. What's the new kid on the block? Did you read my slides before? Yeah, yes. Oh, did I publish them already? So yeah, OpenTelemetry is out there. And it's not a new tool. It's basically these four things. It's protocol, it's a bunch of SDKs, it's a bunch of singles. And there's actually more than 3 singles, although most people just stop with 4. And then there's the auto collector. And if you look at it, it's one of the most important CNCF projects at the moment. To me, it's probably even more important than Cube. But what it really is, it's an abstraction layer so people can switch to a different backend on demand. Like, you want to test a new backend, you want to test a tracing tool or a metrics tool or a log tool, just put OpenTelemetry collector somewhere, ship your data there, and you can change the backends around. And that, to me, is the power of OpenTelemetry. And they claim auto-instrumentation. Because that's something we said initially, you don't want to be able, you don't want to have to change your code. You don't want to have to modify your code in order to get to observability. So OpenTelemetry claims to do that for some languages. I'm still not sure. I mean, these people, back when that platform had still relevance, but they moved to other platforms, luckily. Like, is this going to work? Does auto instrumentation work for you? I see people nodding, nope. I don't think so. I think you need to do some parts. Is there magic? I think maybe there is magic. So, who knows eBPF? Hey, a bunch of you are really awake, and human beings too. Cool. eBPF to me is basically a marriage of S-trace and TCP dump on steroids. It allows you to really build a monitoring tool on top of it. It's a really good framework to really dig deep on what's happening on kernel level. And there's a bunch of tools popping up that allow you to not have to do this manually. So about a year ago, I was researching those tools, figuring out how to actually do this. And I came to a bunch of these tools, like eBPF exporter, OpenTelemetry, Falco, really security-focused, Pixie, Odigus, all those things. And what really struck me is that most of those tools, if you're running Kubernetes, they worked out of the box. If you were not, you were out of luck. So, question to you. Who is today running 100% of their workload on Kubernetes with nothing else out there anymore? I see 2 hands, and yellow is still... 2 hands, I don't know how many people are in here, but that kind of is reality. Yes, there's people who have that use case, but most of us have a whole world out there. We have other platforms, we have other stacks. And all of these tools are really hard to get to work there. And we want to have those benefits of being able to use eBPF and all those things outside of Kube. And that's what I started looking for. And actually found a tool that did this for me. And that tool is obviously what this talk is about. It's Coroot. Hard requirement, if I find a tool, it has to be open source. This one is. It is really cloud agnostic. You can run it on bare metal, you can run it on Kube, you can run it on Nomad, you can run it all over the place. It just fits all the systems. It's basically an eBPF-based exporter, actually is a permissionless exporter. You can scrape the metrics from there. There's nothing much to configure. It's really no instrumentation needed. It does both application and eBPF-based tracing, so you can put an OTel gateway, do that too. And it really helped me. And that's what this talk is going to be further about. So what do I need to get that going? You need basically 2-3 big components. You need a Prometheus compatible data store, something like Prometheus, Tanos, Mimir, Cortex. Actually, yesterday there was a new release. You don't need that anymore per project, but well, I didn't really check out the new release yet, but there supposedly is now a new function that you can actually prefix things and you don't need per different project you're monitoring a new Prometheus instance, so that's something that's changed. More on that later whenever I figure it out. Is that me? No, that was not my. So you need a Prometheus compatible backend. You need to make sure that it actually accepts really long labels, because Coroot actually stores really long labels. It stores also your metrics. Then you need ClickHouse. ClickHouse basically to store all the traces and all the logs. They have support for cluster tables in there in the default installations. And if you want to do this in production, clustered, you also need Postgres for the project information and things like that. I'll come back to what projects are and things. If you just want to run it locally, it can be a SQLite database, so not really. But I don't think I need to tell what Prometheus is more. Most people will know, maybe point out that there is a long-term support release that we built and manage. These are potential backends that you could use because they're multi-tenant. And for those who don't know ClickHouse is basically an open source column-oriented database, which is really fast for analytics, which is really fast to get your data out. What it really is nice, it's SQL-like comments. So if you're used to MySQL or things like that, you can really fast query the things that you want to do. Sometimes if I really want to do something fast, I just query my metrics in ClickHouse because I'm still more familiar with SQL than I've ever been with PromQL. Might be an old fart, but just works to me like that. ClickHouse actually is also one of the OpenTelemetry collectors backends that you can use. If you use ClickHouse on OpenTelemetry backend, then you'll see that these are the databases it creates by default, and this is actually what Coroot uses. They've added some more tables. So it's things that already exist which have been built up on. One of the really nice features of ClickHouse is that you can have a time to live on a table. So if you keep in flowing data, you basically says, keep me all the data to today minus 1 day, and then all the other data gets automatically purged. So you can limit how much data you want to keep in a certain table on demand, and that's really good. So typically with lots of the telemetry systems, you get so much data in there that your disks start exploding. ClickHouse is kind of helping you there by limiting the data that you want to put in there. So we need a Prometheus, we need a ClickHouse, we need a Postgres, and then there's plenty of options to actually deploy Coroot. There's Helm charts out there. I actually have Puppet modules published. You can do it in Docker, you can do it in Docker Swarm. Upstream provides a bunch of curl scripts, curl pipe shell. If that's your kind of poison, you can use that. It's not something I want to advise people to do. They provide binaries, but not packaged yet. I'm working on RPMs. If you're interested in RPMs, I can probably make that repository public if you want to. So what you need to do is basically install a server. That takes us a bunch of parameters, the initial configuration for Prometheus and ClickHouse. And then from the user interface, you can start creating more projects. A project typically is an isolated group of services that you want for one team or for maybe your infrastructure. Could be split over development or acceptance or production. And then from that UI, you can, per project, also configure their specific Prometheus or ClickHouse backends. Second thing you need to do is install a node agent. That node agent actually, once you create it in the user interface, once you created a project, you get an API key. Well, project name is not really a key. If you configure that in the node agent and you start it, then things start happening. And you need to be a little bit patient, and your ecosystem starts working. And what it does, it basically ships all eBPF-based metrics, logs and traces it finds on your server. It is an actual Prometheus exporter, and then things start working. And we'll see in a bit what it looks like. I was planning on doing a live demo at some point, but given the shaky conference Wi-Fi, probably best not to try. So next to the node agent, if you're running specific services, things like MySQL, Postgres, or I'm not going to call those things databases, you can have the Coroot cluster agent, which is a specific agent that can get even more information out of these specific talks, out of these specific services. For example, it really could help me to get really more details on MySQL databases. This is a screenshot from an outage. We figured out that MySQL was really misbehaving because we added the agent. So those are actually the three components: the server, the node agent if you want to, and the node agent you need, and then the cluster agent if you really want to. I mentioned projects and namespaces. So the project actually mapped an agent with an API key to Coroot to the system, and then you can choose in the UI between the different projects you have configured. Within those projects, if you're running a container ecosystem, you can still have different namespaces. So you could have a Coroot per cluster, you could have multiple clusters per Coroot. It's really flexible on how you do all of those things. So after a couple of minutes of things running, this is basically what you start looking at. You get a page where Coroot figures out, hey, this is what your ecosystem looks like. It's going to tell you a bunch of good and bad things. The red stuff on top is the bad stuff, like console here has a latency latency problem. This MySQL has a bunch of errors, 12% of errors. There's a bunch of failed connections. And then there's things with some warnings, not that much. And this is what runs out of the box. No configuration at all. It just starts to figure out, based on what it sees on the network, what's happening. And that to me was like, that's a good start. And I need to figure out what's going on. It's not going to tell me anything, but it's a good start. And then I saw this screen, and I was in love. Because this is what PacketB gave me too. It gave me a live overview of which components were talking to which systems. And you can filter them out, because this is just the application, like right here. You can add the monitoring part, and then you see more components. And you can add all the security parts that we added. And you can filter those groups. You can basically, based on some regular expression, create groups and filter them out and really zoom in on what level of applications you want, what type of applications you can filter out the traffic you don't want to see. And you can get a good overview of what is really running in your ecosystem. I was showcasing this to a couple of colleagues, and at some point, one of the colleagues said, hey, this is awesome. That means that guy who never documents something now has been replaced by a tool, because we can see how the application works when it actually works, and not how he figured out it was gonna work and never did. I was like, yeah, that's right, but maybe we should learn him to document stuff. But still, it was for them a really helpful improvement. In that same view, and this is filtered, you can actually see where problems are. So this is Prometheus having a problem trying to connect etcd because there's failed connections. And then you can start drilling further. Why could it not connect? Because it was a DNS problem, obviously. It was kind of funny that a couple of weeks after I started getting interested in Coroot, they added a DNS feature, which gives me really good insight in what's happening with most nodes, how many requests they're doing. If there are failures happening, well, not in my ecosystem, but you can see what's happening. Like if you see DNS errors in here, it's going to be really fast and really easy to see them. So you get incidents then. And you can, from here, drill down to different parts. You get them all in one space. This is what's going on. These are the incidents. And what I really, really liked about it is they have, in the time frame here, once you go into an incident queue, it actually maps your time frame to the period of the interval. I mean, the amount of time I spent looking in Grafana for, oh, when did the incident start? Okay, I need to change it and resize it and fill. No, Coroot just says, hey, this is the time frame of the interval of the incident. Oh, okay, cool, that works. Let's have a look at another incident. What's happening here? Oh, there's a huge error budget here. I mean, I mentioned a bit, they have this vision of SLO-based reporting, SLO-based monitoring. So they basically have, you can have this error budget, and once you get above that, you can configure that, and you get all of these errors. You get a view, and then you can see all of these details, what's happening here. So, I mentioned tracing, right? You can get either as an OTel endpoint where you ship the traces to, I haven't done that yet, or it gives you traces right out of the box, eBPF based. And that error, that MySQL error, was actually MySQL exporter trying to do queries that it shouldn't be doing for that MySQL version. I was not even looking for such a problem. MySQL de-exporter, application-wise, not an issue. Not really a problem if that doesn't work. But I figured out really fast that, hey, these queries shouldn't exist. I learned something from the platform. I learned how things work, and these are just the plain traces. And this actually is a span on how that thing worked. And you could do that for different applications. This is just an example. You can really see fast and easy into that whole ecosystem. Same with logs. I loved Logstash back in the days when Jordan started working on it, and then the dashboard started getting more complex, difficult to use, and even finding the logs in Kibana at some point became to me like, well, what did they do here? Coroot made it easy for me again. I don't need to set up something complex. It just basically tells me, hey, filter on all the errors I see, filter on all the warnings I see. And you get them per process really fast, really quick, without really having to build complex dashboards. So it obviously does alerting. Do you want these things as alerts? For me, no, not yet. It's, for me, a debugging tool. Might still evolve. I still have Nikinga there. I still have things that really are actively checking. But it gives me an insight into things that I need to look at or might want to look at or help me with debugging. You can configure them. You can send those alerts to all the things you want. We're shipping them to Rocket Chat, and that's a channel where once in a while, if you see there's traffic happening there, maybe something is going on. But it's not something that we're actively working on, because the problem with SLOs to me is that it depends on your ecosystem. Large organizations, you can actually figure out that something is wrong if you see a drop in traffic. A government organization that shuts down at 4 o'clock, yeah, no, because you don't have sufficient data. How do you deal with SLOs in that kind of environments? If you're having teams where you say, hey, you have this error budget, but a lot of organizations don't have the culture to be able to enforce that. So it's really, for the right environments, for the good companies, culture, I love it. But for some, it's a gimmick. So which of the pillars did I not talk about yet? I didn't share a screen of default CPU metrics. Obviously, you can find it in there. I showed logs. I showed traces. You really did see my slides before. Profiling is Periscope based. It's in there out of the box. This is that the Golang example? No, this is the Python one, and this is the Golang one. So it's basically limited to whatever Periscope supports. But it really is useful. You see what most people see. And there's even more. I mean, I've only used open source. They have a bunch of things that are not open source too. These are all in the open source version. They have cost calculations on things you do on public cloud. If you're on EC2, you can actually get things there. If you're doing deployments on Kube, you can see when new deployments happen. That's the thing that I haven't played with. They have root cause analysis in there. So Coroot to me was like this tool that I bumped into that gave me all the joy that I had with tools before. I mean, it informs me where to look. It's really good as a debugging tool. Right now, I have it fully enabled in all our development environments. It's not yet fully enabled in production yet. It's feature flagged. We can enable it where we want. One of the reasons is that I still need to manually create all the projects. Once there's an API for that, it's going to be much faster. Another reason was that we needed all the multi-tenant Prometheus backend. But with the new release, that's probably also going to change. So I really fell in love with this tool. I mean, I always loved monitoring done right. I was trying to get really enthusiastic about a bunch of the observability tools, but they were so complex to set up and so hard to work with. And Coroot really gave me back that love. And I mean, I hope that if you have a similar challenge, you have a look at Coroot. It's a happy, open community. They're really fast to respond to questions on their Slack channel. Well, still too bad it's Slack, but okay. So I'd say give it a try, and who knows, you're also going to fall in love with a new tool. Thank you.